Hey guys, sorry I'm getting a little bit of a later start today. So I'm posting this I will be posting this a little bit later. You can see the time up top, it's already 11:15. But such is life, we will move forward. I was really pleased with the responses that I got. I think there were maybe a couple people that were a little off, but for the majority of us, we were spot on. So I'm not going to spend a whole lot of time, but I am going to go through this. So the first thing that we need to do on these homework problems is we need to put theta in the correct spot. So for problems 1, 2, and 3, theta should be here. So when theta is here, that means 2 should be the O, the opposite, and then 3 is the adjacent. All right. And then we need to do Pythagorean theorem. So we'll do 3 squared plus 2 squared equals c squared. So that's 9 plus 4. So then that's 13 equals c squared, and then we have to take the square root. So c equals the square root of 13, okay? So c is our hypotenuse, and that is our h. Okay, so now we can answer the questions. So sine, let me zoom in a little bit. Sine is the O. Oh, let's do a reminder. Let's do SOHCAHTOA. SOHCAHTOA. Like I said, that should kind of be written down each time. All right, so sine is O over H. So O is 2 and H is root 13. So 2 over root 13. And then we have to rationalize, which means get rid of that radical. So your final answer should be this, okay? A few of you had 3 root 13 over 13, which means you just had your A and your O labeled incorrectly, okay? So just make sure of that. Then number 2 is cosine, which is A over H. So A is 3 over root 13. And then we got to rationalize. Okay, and then tangent is O over A. So our O is 2 and our A is 3. Okay, now you could put 0.6 repeating, but like I said, I don't think anybody did that actually. So I prefer it like this in fraction form, okay? Because we're using those word ratios, which we reminded each other yesterday, that means fractions. All right, when I move my theta now, I'm going to move its position to S. What does this now become and this now become? Basically, it just switches the two of them, right? So now this one is the adjacent and this one is the opposite, okay? So then sine is O over H, so 3 over root 13. Okay, and then hopefully we're seeing some kind of similarities. And then the second one is adjacent over hypotenuse. And then tangent is now, it's still O over A, but now those two have switched, so now it's 3 over 2. All right, so those are the numerical answers you should have, and then you should see make some observations. So what do we know about number 1, the sine? Let's change the color. Number 1 and number 5. So basically the sine of one and the cosine of the other, they're the same. Okay, what do we notice? Number 8 says, what do we notice about cosine of r? So number 2 and number 4, they're the same. Most of you put the same, which is totally fine. And then what do we notice about 3 and 6? And most of you use the word flipped, okay, which is totally great. Some of you said the word opposite. Do not use the word opposite. Opposite means one's positive and one's negative. Flipped is better, but the best word, flipped is okay, but the best word is reciprocal. Okay, which means flipped, which I totally 100% am fine with you putting this for now. But now that we know reciprocal, I'd like you to write that, okay? Awesome. Now, this is not a coincidence, you guys. This relationship, the sine of R and the cosine of S will always match up, and then the cosine of one angle and the sine of the other will always match up. So that's just something we want to kind of look at in the future as we continue to work through these problems. All right, so today we're going to just like up the ante a little bit, which basically just means we're going to make it a tiny bit more difficult. So the way that I'm going to do that is I'm just going to take away the picture, okay? And you have to be able to draw the picture and fill in the appropriate sides. So let's look at this. This is where we pick up on our notes from yesterday. So we're just finishing the notes, okay? All right, so it says, suppose angle J and angle K are complementary angles in a right triangle. So let's remind each other what this means. Complementary means the sum is 90 degrees. So that means the two angles that are not the right angle will be complementary. And that makes sense because a triangle should be 180 degrees. The value of tangent of J, so it's important that we're talking about J, is 12 over 5. What is the value of sine of J? All right, so this is what we're looking for. So step one says, draw and label a triangle for the problem. Now you guys, I'm a creature of habit. My right triangles are going to look like this every single time. And so it says J and K are complementary. So it means they're the ones that are not the right angle. Okay? And it says the value of tangent of J. So whenever I'm talking about the letter J, that's where your theta goes. Okay? And I'm giving you tangent, all right? So this right here is very, very important because it goes with our SOHCAHTOA. All right, I'm going to write it down up here. So I'm giving you tangent, which is what two sides? It's the opposite and the adjacent. Because that's the definition of tangent. It's the opposite side divided by the adjacent. So if I put my theta here at J, then the opposite side goes here, the adjacent side goes here, and now I can put the 12 in this spot because that goes with the opposite, and the 5 goes with the adjacent, so it goes here. All right, so I gave you a lot of information in this little sentence here for you to be able to draw the picture. All right, step 2 says, use the given trig ratio to label the lengths of the two sides. All right, we just did that. Then use the Pythagorean theorem to find the third side. So we need to find the hypotenuse, correct? Everybody okay? And so we're going to do that using Pythagorean theorem. So we're going to do a squared plus b squared equals c squared, and do 12 squared plus 5 squared equals c squared. And remember, it's okay to do 5 squared and then 12 squared. Okay, so this is 144 plus 25 equals c squared. Now let's add those two together. That should give me 169. And you may not know this one, but it is a perfect square. So if you type in your calculator second x squared and then 169, it'll pop right back that it's just the plain number 13. So yay, we don't have to worry about radicals. All right, so I'm going to put the 13 there in the hypotenuse side, and now it says, using the measures of the sides of the triangle, find the sine of J. So remember, this was our actual question. What is the sine of J? So our theta is going to stay at J, and we want sine. So what two letters do I need for sine? For sine, I need O and H. So what's my opposite side of J? It's 12. And what's the hypotenuse side of J? It's 13. And there's my final answer. So you really need to draw the picture in order to solve the problem. Okay? All right, let's do another one without kind of listing out all the steps and see if we can do it a little bit more quickly. All right, it says, suppose A and B are the complementary angles in a right triangle. So let's go ahead and draw our right triangle. And no tricks here. And you guys, you could switch the A and the B. That makes no difference. Everything we're going to be doing is a right triangle, so there's going to be no surprises about that. The value of the sine of A, so that means my theta needs to go here. Now, you guys, if you had put A here and B here, then your theta would go down here, right? So it's totally dependent upon where you put that theta. I just want you to understand that there are multiple correct ways to do it, okay? All right, so then my opposite side is going to go here, my hypotenuse side is going to go here, and my adjacent side is going to go here. Is everybody okay with that? And so now I'm going to do sine. I gave you sine here, and it's 7 and 14 are two of the sides. Well, you just have to remember, what does sine stand for? Well, sine stands for the opposite over the hypotenuse. So I gave you the opposite side, which is 7. So I'm going to put 7 here. And the hypotenuse is 14. And now what is it asking us to find? It's asking us to find cosine. So I'm going to make this little note over here. Cosine of A is the adjacent, because of, let me go back up right here. So COA is the adjacent over the hypotenuse. All right, so we don't know the adjacent, but we do know the hypotenuse. Okay, so we just need to find the adjacent side. So how do we do that? We're going to do Pythagorean theorem. A squared plus B squared equals C squared. Now you got to be very careful on this one. Notice that I gave you the hypotenuse, so your 14 has to go in for C. Okay, and then I don't care if your variable is the A or the B. Okay, does that kind of make sense? You got to be really careful here, because the other ones that we did, I didn't give you the hypotenuse. This time I am giving you the hypotenuse, so you got to do it a little bit differently. All right, so 7 squared is 49, and 14 squared is 196. And now what do we need to do this time to get A squared isolated? We need to subtract the 49. Okay? So A squared equals 196 minus, what is this, 49, is 147. Okay? And so then we need to try to break down 147 if we can, because we need to take the square root of it. And I think it does break down. Let's check really quickly. So I'm checking. I couldn't remember it off the top of my head, and I should have worked it before. But 147 is, so I'm starting with the, sorry, I'm trying to think through my head and talk at the same time. That's not working. It is one of those numbers that looks like it's prime, but it's actually not. So 147 can break down. What I'm thinking through is I'm thinking through these guys. Remember the perfect squares? Okay. Now, I'm going to tell you kind of quickly, I looked at this and saw 147, but I also see a 14 and a 7. So that kind of to me means maybe 7 will go into it. And if 7 goes into it, maybe 49. That's kind of my thought process. Anywho, I did find that 49 goes into it. Okay, after typing it in. And the square root of 49 is 7. So with this simplifies, it would be 7 root 3. Okay, does that kind of make sense? Sorry, I was kind of stumbling over my words there as I was thinking. But so we had to do Pythagorean theorem and subtract, and then 147 does break down. Our perfect square is 49, and then we have 7 root 3. And now that's the adjacent side, so it can go here. And then we just need to ask ourselves, are we done? Is that radical okay being in the numerator? The answer is yes. Is this fraction simplified? And that answer is no. So our final answer should be root 3 over 2. And the reason is because what number goes into both 7 and 14? It's 7. All right. So there's our answer. So drawing the picture is so important. Labeling the sides is the next most important, and then, finding the third missing side using the Pythagorean theorem is the next step. Okay? All right, so you have 2 to try here. All right, so for these 2 problems, you're going to be using this information here. And then for these problems, you're going to be using this information here. Don't be alarmed by the square root, okay? When you do Pythagorean theorem and you square a square root, think about what they do to each other, okay? They should cancel each other out. So that's a big hint that hopefully will help you. So I'll leave you with that. And I'll make a form to have you tell me the answers for 10 through 16 so I can see how you do. Awesome.